Hi everyone, so welcome to the problem session from electric field. This is problem number 56 from Resnick Halliday Walker, 10th edition. This is basically on the basis of electric dipole. So they say that an electric dipole consists of the two charges plus 2 and minus 2e separated by a distance 0.78 nanometer. It has an electric field of strength 3.4 into 10 to the 6 Newton per coulomb. This is the magnitude. Then they say that calculate the magnitude of the torque on the dipole when the dipole moment is parallel to, perpendicular to, and antiparallel to the electric field. Okay, fine. Say, what is the electric dipole? Before we start, we have to recall that one. Say this is your electric field. This is the direction of electric field. This is the electric field line I'm going to draw. So this is one line. This is one line, and this is line. Say if I kept two charges with the same magnitude but in the opposite polarity, say this is a plus q and say this is actually the minus q. If we keep an electric field, then it will create a dipole moment, so that the direction of the dipole moment would be towards that direction from negative charge to the positive charge. And we define that this dipole moment we can express P actually the Q into D, where D is the separation between the charges. So this is actually that D. If the case is that, then think about it will create a torque. How it will create torque? Say this positive charge will try to move towards that direction. The force, we know that force on a positive charge, right? If you apply a test charge in the electric field, that charge will move in the direction of the electric field because the force will be towards that direction of the electric field. On the other hand, the force on the negative charge will be towards in opposite direction, right? So this is, you can say this is the force on negative charge and this is the force on the positive charge. So these two forces, then it will create a torque, and that torque we write down that formula. The torque on that case would be, since torque is a vector, it would be that dipole moment cross electric field. This is actually formula we can derive from there, and say is create an angle with that electric field, or I can draw because the electric field is towards the direction of the electrostatic force. Say in some case, so this is the electric field over here, and it's this electric dipole P is create an angle, the theta, with the electric field. Then we can also say that the magnitude of this torque, which would be the P E into sine theta, right? So this is would be actually, since it's a cross product, we can find out that the magnitude of this torque using that formula. And to find out the direction, we can use that right hand rule. Actually, I have to put my forefinger in the direction of the first vector, which is the P over here, and if I rotate my rest of the finger towards the electric field, then my thumb direction will give you the direction of the torque. In that case, it's going to be basically into the base or into the screen. Fine. Now, what this torque will try? So basically, this torque will try to align the electric field in the try to align that electric dipole in the direction of the electric field, right? So since this is my direction of the electric field, and it will try to rotate that dipole moment P in that direction. Now they ask me, find out in this question if this electric dipole moment is parallel to the electric field, anti-parallel to the electric field, and perpendicular to the electric field. Then what would be that magnitude of torque on the dipole. Fine. In the first case, when this case, when that electric dipole, this is the P, is parallel to the electric field line, right? So that's mean these two vectors are parallel. In that case, we can say that the theta is basically 0. So we can find out in that case torque would be sin theta is 0. So that's why your torque would be also that 0. So this is actually answer number 1. Fine. In the second question, when that torque, what will the torque when the dipole is perpendicular to the electric field? So this is the case where, say that in the case of P, so this is actually your electric field E, and this is actually your electric dipole P, right? It is perpendicular to that electric field line, so which is mean that theta is basically 90 degree. Fine. So then I can find out now the torque, the magnitude of the torque would be basically that torque, so P into E, the sine theta, which is P into E sine 90, that would be P into E, right? Now what is P? P is actually the electric dipole that we define, charge into the magnitude of the charge and the separation between that charges, which is the D. So now the charge for this case is basically that twice E, we say that, and the separation between that, we can say that the D, that D would be 0.78 nanometer. They say that they separate by a distance 0.78 nanometer, and the electric field strength is 3.4 into 10 to the power 6 Newton per Coulomb. So then if we plug in that value, we can calculate the magnitude of torque. So what would be that case? So I write down this is 2, this is the magnitude of this charge, 1.6 into 10 to the minus 19 into D is 0.78 nanometer into 10 to the power minus 9 into the electric field strength, which is 3.4 into 10 to the power 6. Now if you do that calculation, you will find out the torque would be 8.48 into 10 to the power minus 22 Newton meter. That should be the torque. This will be the torque on that case. So this is your answer number 2. Now this third case, if it is anti-parallel of the electric field. So what will be the case? So I'm going to draw for you. Say this is the electric field E, and say this is actually that electric dipole, right? They are anti-parallel. In that case, this angle is 180 degree, right? Theta would be 180 degree over here. So the torque you can write, so PE sine theta, now theta is 180 degree, PE sine 180 degree, and sine 180 degree basically then 0. So that's how we can say that the torque would be also the 0 in this case. So that's how actually we can find out that torque for due to the electric dipole in an electric field. So torque would be maximum when basically these two vector dipole moment and electric field are perpendicular each other, whether it is parallel or anti-parallel. In that case, the torque would be basically the minimum. So this is the answer of this question. Okay, thank you very much.